Hello, the internet, and welcome to Open Source Directions. Hosted by Quansight, the webinar that brings you all of the news about the future of your favorite open source projects. My name is Anthony Skopatz, your host for Open Source Directions, and co-hosting with me today is David Charbonneau.
Hi, I'm David Charbonneau, and I'm excited to be the co-host for this episode of Open Source Directions. I lead the development of open teams at Quansight, and I'm currently visiting Eva Beach, Hawaii.
Nice. And our guest today is Safia. Safia, do you want to go ahead and introduce yourself?
Yeah. Hey, I'm Safia. I am a software engineer, and I am an open source maintainer on the nteract project, which is what we'll be talking about today.
Excellent. Yeah, it's really great to have you here, Safia.
Yeah.
So before we dive into the episode, we do a brief sort of personalization section. And this week, we've got some headlines for you all. So first up, Safia, what headlines have you been enjoying recently?
Sure. So there is an online and actually in print magazine called Increment. It's a technology magazine. They issue out different issues throughout the year, and each issue has a different theme. The most recent issue had a theme around open source, and there's a really interesting article in there called The Lingua Franca of LaTeX that talks about the history of LaTeX all the way from its inception to the fact that it's still a well-maintained software project, and some of the impact it was able to make on technical publishing and publishing in the digital age in general. So if you're interested in LaTeX and if you're interested in what it is to have a software project that is decades old, that's a really great article to read.
Very interesting.
That's excellent. Sounds cool.
Well, I grew up playing, one of the earliest memories I have of a computer is a game called Rogue. My dad had brought home from work a grid laptop, and very few people probably know what that was, but it had like a monochrome LCD screen, and Rogue was just this game where you wandered around in a dungeon. It was a text interface. You fought monsters, you found treasures, and I don't really read the news anymore, right? Things just pop up in different feeds, and somebody has decoded a port of Rogue to DOS from like 1983, 1984, which might be, roughly the version I had actually played. But they're doing code walkthroughs, and it's, there's the nostalgia factor for this. There's the code archaeology or code exploration as a kind of archaeological expedition struck me as a really interesting concept. So I haven't had a chance to go deeply into his walkthrough, but it looks really fascinating in terms of exploring how that project had been structured at that point.
Yeah, that sounds really cool. I'm here at SciPy 2019, and I just want to say that there have been some amazing keynotes this year from Rachel Thomas, Stuart Geiger, and our own Carol Willing. So be watching for those to hit the nthought YouTube channel and be sure to check them out. They're really quite impactful. So at this point, we're going to get into our project introduction. So we're going to talk about sort of what nteract is and where it comes from. The nteract project is an ecosystem of open source tools that help to enable people to build their own front ends and workflows on top of the Jupyter ecosystem. So it's a suite of tooling on top of Jupyter. It's got about 4,200 stars on GitHub, and downloads per month, it's about 1,000 for the desktop app, over 1 million for the hydrogen atom extension per month, about 6,000 downloads for the React components, about 6,000 downloads for Papermill. And so we'll be getting into what those things are during the course of this webinar here. And so, Safia, we just have some questions that will help introduce the project.
Yeah.
Go ahead and ask the first one.
Yeah, Safia, why was this project started, and what need does it fill?
Yeah, so I'd say the project was started out of a need to provide users, and this is particularly developer users, with an ecosystem of composable and extendable front-end components for building their own Jupyter Notebook interfaces. When we started building nteract, we started by kind of dogfooding our own technology. We released a desktop app, which is generally what people think of when they hear the term nteract, but it's actually expanded to quite a bit more. So when we started by developing a desktop app using a pretty popular technology called Electron. For those who might not be familiar, Electron is essentially a Chrome sandbox that can run on the desktop. And what this enables people to do is to write using web technologies, HTML, CSS, JavaScript, React, any of the above, and then compile and ship for different operating systems. So it reduces the barriers that users have or developers have to shipping for the desktop. And it also makes it a little bit easier to develop for the desktop because you're not having to learn low-level APIs that are specific to each operating system or target that you're shipping for. So when we started by building this desktop app using web technologies, and the web technologies that we developed were actually built with the intent of being consumed by other people in a variety of ways. And I'll show you what I mean by that a little bit later on, and as I talk about the different use cases for it. So yeah, it kind of started off as a front-end technologies project, but it expanded. We now have Papermill within the nteract ecosystem. We have Scrapbook within the nteract ecosystem, a newer project called Bookstore within the nteract ecosystem. And these are essentially all allowing people to build workflows on top of Jupyter notebooks. So where we started and how we did it and where we ended up been an interesting journey.
Yeah, that sounds great. I'm really looking forward to the demo of this episode in particular.
This is going to be exciting.
Yeah.
So are there alternative projects to nteract out there, or the various nteract projects rather?
Yeah, so that's a great way to put it, because there's, again, nteract is an ecosystem. There's quite a few alternatives with respect to notebook-based front ends. You've got Jupyter Classic, you've got Jupyter Lab. I would say Zeppelin might be considered a notebook front end because I think people perceive it in the same category of things. When it comes to Papermill, I would say that NB Convert is a little bit of an alternative, although interestingly enough, if you look at the source code for Papermill, it actually builds on top of NB Convert. So perhaps they're complementary in that sense, but NB Convert is an alternative. We have our Hydrogen Atom extension, which is essentially an interactive extension for the Atom code editor that allows users to execute their Atom code in the same way that they would execute it in a notebook. So you can execute certain sections of code, view those outputs interactively. I would say in that regard, one of the alternatives is the Python interactive extension on VS Code, which is another text editor. But I'll actually circle back and say one of the most interesting things that I learned about the Python VS Code extension is that it actually also uses nteract under the hood for some rendering of outputs. So again, maybe it's all synergistic in that way. So what I think is cool is like there are alternative projects, but you tend to find elements of nteract within them or in them. And I think that's pretty interesting position to be in for a project. And then for newer projects like Bookstore and Scrapbook, I'm not aware of any alternatives at the moment. But yeah, I'll keep my eye out and see if anything comes up.
Great.
Yeah, that's cool, the way that everything's kind of interdependent, the way you described.
Yeah.
But what technology is nteract or the nteract ecosystem built on?
Sure. So I can talk a little bit about our front-end technologies. For the front end, we use React components for a lot of the UI elements that we ship as part of core nteract. So these are components that allow people to create, code editors and output views, prompts, all of the different components you might need in a Jupyter Notebook interface. We use a technology called Redux for client-side state management. So this is what we use to store the in-memory representation of the notebook you have open when you're on the web. And this is what we use to manage state in the client side. And then for another aspect of our front-end technologies, we use a tool called RxJS, which stands for Reactive.js. It's part of the popular Reactive-X paradigm, which is essentially an ecosystem of implementations in different programming languages. So there's RxJava, RxC#, so on and so forth. that essentially allow you to kind of do reactive event-based programming. And so we heavily use RxJS as the layer in which we communicate with the Jupyter kernel. So we use that to send messages to Jupyter kernels, to process responses from Jupyter kernels. I can dive into what that means exactly for those who might not be familiar with the internals of the Jupyter ecosystem. And then, as I mentioned earlier, we're using Electron to package and bundle our desktop app for the web. What's really cool about this is that we have an nteract web app, and then we bundle that, and we have an nteract desktop app. So that's kind of really fun to be able to do with Electron to ship across both the web and the desktop using one code base. Python, obviously, for things like Papermill and Scrapbook and Bookstore. We build on top of Jupyter, so we rely on those protocols and the specifications that were pioneered by the Jupyter ecosystem. And yeah, I would say, I guess we could tie in not just, the programming language technologies, but things like Circle CI for CI/CD pipeline. We use a platform called Zeit, which is how we do our deployments for our websites and our documentation and how we automate all of that. So yeah, tons of stuff going on in the nteract project. I always like to say, regardless of what aspect of technology you're interested in, whether you're a front-end person, a back-end person, or you're interested in DevOps, there's an opportunity for you to help out the nteract project.
Yeah, that's great. We'll touch on that more later in this episode, I'm sure, too. So who started the nteract project and the nteract ecosystem at this point?
Yeah, so that's a really hard question to answer. When I looked at the script earlier and I was thinking about this, it's so hard because I am of the opinion that you can't necessarily attribute the creation of an open source project to a single individual. I think that's kind of culturally a bad thing that we do in open source, where we give credit to a small or a single group of people or a single person for the starting of a project. Like, I think it's inherently a collaborative effort. I know that's not always the case, but that's my perspective on it. So my answer to that is that quite a few people started the nteract ecosystem. There's Kyle Kelly, myself, Lucas Geiger, John Detlefs, Peggy Razius, Carol Willing, I would say, was foundational in that. We have people like Matt Seal and Ed Pacer starting projects. So I think what's interesting about nteract is it's not a singular project necessarily. It's this ecosystem, and anyone who exists within it or knows about nteract and has an idea can come contribute. And so there's multiple people who have started projects within the ecosystem.
So who maintains the project today, given that broad array of initial contributors?
So I'd say the project is maintained by members of the community, some of them who are listed above, and then others who have joined afterwards. Some of these people contribute in their spare time, and then some are contributing as part of their full-time roles at their companies. Perhaps their company takes a dependency on nteract in some way, and they contribute to nteract within that full-time role. So yeah, it's a mix of community and I would say kind of part-time corporate contributors. And that's who helps maintain the project.
That's great. So where are the users of the nteract ecosystem coming from? Are they, you answered the contributors already, but where is your user base and who is your user base?
Yeah. So in some senses, our user base overlaps with the user base that you might traditionally expect from a Jupyter notebook. We have people who come in from a data science, education, and academia background. We have some people who come in from a web technologies background and are entirely interested in using nteract to develop other front ends. I would consider them users of our SDK. And then we have people who come from a data visualization background or a data analyst role that's not as technically intensive as data science, but they're relying on data. They're coming up with analytics. They might work in a product management or business analytics role. So I would say these are the communities that our users come from.
Is the project participating in any diversity and inclusion efforts?
Ooh, so I forewarned Anthony and David that I have a little bit of a rant to go in about this question. So
Please.
um, my answer on the script is simply yes. And one of my personal philosophies as someone who is an underrepresented minority in open source is that I try and not think of diversity and inclusion as an effort that is separate and independent of the day-to-day operations of your project. One of the things that I've seen in open source projects is there's this tendency to view the main priorities of the project, delivering on your roadmap, addressing user feedback, providing support, raising funding, all of this stuff. And then diversity and inclusion is sort of this like side priority that is attached as a goal at some point, when really I think it's just a way that your project proceeds and does things. It's the way that you go about responding to user feedback, providing support, managing your organization and your repo on GitHub or whatever other online social coding tool you use. So I don't like to think of it as, participating in a diversity and inclusion effort, because that kind of treats it as diversity and inclusion being separate of just existing as a project. I've always tried to emphasize that it's not completely separate of our day-to-day operations. It is our day-to-day operations. There's no ifs or buts about it.
It's not a thing you do, it's how you do things.
Yes, that's a great way to describe it. And so I guess, yes, because our very existence as a project is based on those principles. And I know that is something that myself and the other maintainers and leaders on the project work hard to maintain. We recently went and we all got code of conduct enforcement trainings that we paid for out of our project budget to learn how do you go about actually enforcing a code of conduct and dealing with reports and issues that come up in a way that isn't going to hurt people or be insensitive or anything like that. So it's an active investment and it's a way of life for the nteract project. So in summary, yes, we are. It's in the way we do things. And I think definitely the fact that when the project started, the names of individuals that I listed off is very diverse. And I think that's a testament to what nteract is and who we are. The fact that all of the names listed came from across a wide spectrum of backgrounds. It's not who you usually see starting projects within the open source ecosystem, and in particular, the scientific open source ecosystem. So I think that's the best proof in the pudding for our approach to things.
Yeah, it's great. It's just been wonderful to see how foundational that your principles are in nteract, and how that really extends to the broader community too. I know I personally really appreciate it. So.
Oh, thank you.
Yeah.
We've asked this question a lot, and that's a really exciting and motivating response that you provided. Thank you.
So now it's time for the fun part, where we do a project demo or projects demo. So if you want to go ahead and share your screen, Safia, we'll get to see some of all the fun things that you and the nteract team have been working on. So
yeah.
So hopefully this, and I think we're going to see some VDOM and paper mill stuff. Yeah, there we are. Perfect. Can you make that font a little bit?
Yes, I think so. I could probably just zoom in to this. Okay, so I want to start off by presenting one of the first kind of web-based applications that nteract develops, which is called play.nteract.io. When you look at Play, it seems pretty simple. On the right here, I've got some sort of output that I'm going to explain what that is in a little bit. And then on the left, I've got some code. I've got some buttons at the top. Pretty straightforward, right? There's actually tons of cool stuff going on under the hood. So play.nteract.io is powered by Binder for compute. We have created a set of packages and components that companies can use that allow them to essentially use Binder as a kind of API, such that you don't have to use the Jupyter Classic frontend or nteract frontend within mybinder.org, but you can query Binder from your own frontend, similar to what we're doing here. So I'm going to run this code, and it's already displayed, but it's actually running within a Binder container, and the outputs are coming back to me and being displayed on the right here. Let me change this, I guess, and then run. And that should do the thing. Oh, this is the problem with live demos, is you should not do them.
Yeah.
All right, let's totally pretend that that worked. So essentially what happens is we are going to take the snippet of code, and the snippet of code is using a specification called VDOM, which stands for the virtual DOM. And VDOM essentially allows you to write Python code that is eventually going to be rendered into a HTML view in the front end. So you can see here I'm creating header tags, p tags, image tags, and span tags, and they're actually being rendered as those HTML components with stylings and colors on my front end. And what this allows people to do is one of the most common use cases for Jupyter is people will want to create some sort of interactive layout for an analysis that they've done, or some kind of like lightweight dashboard or view. And VDOM fulfills that role. It essentially allows you to write HTML in Python or any other language, send it over to a front end, and then render it as HTML. So this is really powerful for business users who are looking to create interactive layouts that their notebook users can consume. And that's one of the probably most common use cases I've seen for it internally at companies. So that's VDOM. That's our example of our Binder JavaScript package. And then you'll see all of the components, the visual components you see here, the editor on the left and the output on the right. Those are our React components that we can export. And what I think is really interesting is a lot of these terms that I'm using do come from the Jupyter ecosystem. You have the concept of an output, an editor, MIME bundles, which are the actual data stored in an output. But this is not a Jupyter notebook. It looks kind of like a JS Fiddle or just a simple text editor environment. And I think that speaks to the power of nteract, is you can use the components and packages that we ship as part of the nteract SDK to create anything really. It's any interactive front end. It doesn't have to be a notebook. And as a teaser, we'll see what the different kinds of front ends that people can create look like. So that's a little bit on some of the front end technologies that the nteract open source project maintains. The next thing I want to jump to is a pretty popular project. Some people might have heard of it. It's a little thing called Papermill. Ooh, that's no fun. I actually have this running up on my Binder, and I had it running up earlier, so it looks like my Binder connection expired. But I can go through what Papermill is, and then talk a little bit about what it does. So essentially, Papermill is a tool that allows you to execute your notebooks headlessly. So you might write a Jupyter notebook, and you might interact with it in Jupyter Classic, polish it up, and then you might throw it into an ETL pipeline as part of your data workflow, or you might throw it up into a DevOps pipeline that your developers are using, and then run it headlessly the same way that you would a computer program. And I think this is a really interesting paradigm because it bridges literate programming and actual code execution in a really elegant way. Literate programming is the notion that programs should be written that can be consumed by a human being. They're designed to be used by people first and executed by computers second. Jupyter notebooks are examples of literate programs because the primary target for them is a human reading a notebook. It's not, the computer running through a text file with some scripts on it. So it bridges this kind of human-focused development style with a way to actually execute that code in a more robust execution environment. So in this demo here, you can actually check it out on the nteract papermill GitHub repo, which if you just go to github.com/nteract/papermill, there's a badge in the README. Essentially what we're doing here is we're going to go ahead and we have a input notebook that contains some code that's going to read some data and then create a visualization that highlights certain parts of that data. And this notebook is going to take parameters, and the parameters in our case are the start date to highlight and the stop date to highlight. So you can see here, I'm taking this input notebook and
Could you zoom the font real quick?
Yep.
Just to make it a little bit bigger?
Yep.
Sorry to interrupt.
No,
Thank you.
No problem. That's a great call. So you can see what I'm doing here is I am taking a input notebook that contains the actual code that I want to execute, and I'm providing it with a set of parameters that are going to be used within that notebook. And then I'm executing it using papermill, which is taking care of piping the parameters into the notebook, running the notebook headlessly, and then creating your output notebook. What can you do once you have your output notebook? Well, you can pair it up with another nteract project called Scrapbook, and you can start to pluck outputs from that generated notebook. So you can see here, I've created my output notebook using a certain set of parameters, and I can see these parameters here. I've got my start date, which is January 2011, and I've got my end date, which is February 2014. And then I'm using Scrapbook here to pluck out outputs from the notebook that I ran before. So I just wrote a notebook in a Jupyter front end, executed it headlessly with parameters using papermill, and now I'm extracting the outputs that were generated by this headless execution, and I'm kind of re-gluing them is the phrase that's used in Scrapbook to create derivative artifacts. So what's a really popular use case for this? Reporting. If you're writing notebooks that generate some sort of financial report, sales reports, and then you're using Scrapbook to re-glue the visualizations created from those reports into an end document, that's a really popular scenario. So it fits into most companies' data pipeline or kind of data production workflows, especially in the realm of reporting.
So is this an alternative to, like, say, having a reporting pipeline that's completely based on PDFs? Or are these artifacts, are these notebooks just something that you can give to downstream analysts or people higher up the food chain?
Yeah, what I think is really interesting about this is it bridges technologies that are used by people who are, leveraging Jupyter notebooks and code on the day-to-day, and then consumers of those technologies at the end. Because I think one of the interesting things in data science in general, or data science in particular, but software in general, is how do you go about translating a document format across the different roles that it goes through? You might have a data scientist who's creating a visualization in a Jupyter notebook, but they need to get it to a product manager who works in PowerPoint, and they need to send it over to an executive who's working in Word or what have you. And I think creating stories where you can bridge all of those different formats and the transitions in a really cohesive way it's a pretty cool scenario for Scrapbook. Because if you think about it, Jupyter notebooks are documents the same way a PowerPoint is a document. Right. The same way a Word document is a document, but Jupyter notebooks are a little bit more flexible and extendable than other document formats that exist out there.
Right.
Cool. So that's kind of at the back end, I would say, or more of the headless execution aspects within the nteract ecosystem. And I want to dive in and take a look at some of the other ways that users can leverage projects within the nteract ecosystem. So I showed you Play earlier, which was a simple Play-like execution environment. Let's see what an actual notebook looks like using nteract. So this is what might be most familiar to Jupyter Notebook users. It's a Jupyter Notebook. It's a multi-cell document with outputs, and it's a place where you can write code, run it, and then execute that code. So under the hood, this is all using React components. The output component is actually the same one that you saw in play.nteract.io earlier, but notice it's in a completely different form. So same fundamental technology, completely different implementation of it. And I think that's what's really cool about Interact, is seeing how people take these composable pieces that we've provided and then build different things with them to match their use cases. So this is an example of a Jupyter notebook, and I want to bring your attention to this little guy in cell number 3. This is something called the Data Explorer, and the Data Explorer is an example of an interactive transform within the Interact ecosystem. And a transform is also a concept that's used in other places within the Jupyter ecosystem. I don't know if it's referred to as transform in the same way, but a transform is essentially some sort of front-end view that consumes a media bundle payload, which is just a media type, and some data that represents that media, and then presents it. So for example, here, what we're doing is we are taking a pandas data frame that is exported in the table schema format, and then we're rendering it with an Interact, and we're using the Data Explorer transform to render it. And Data Explorer is an interactive component. So this is the data in my data frame. I can kind of play around with it, explore it, and visualize it in this way. I can filter through it. And the filters, I think, show up at the bottom. We can sort through it. But we can also do other things with it. We can switch to a visualization view. So we can view the data in the data frame using a bar chart. And this is without having to dive into Matplotlib or Seaborn or any of the other plotting technologies. And this is a great way to bridge the gap between just wanting to explore data in a really simple and friendly way versus having to create formal end user graphics from that data. So this is just a fun tool to play around and explore your data with as you're kind of starting in the initial phase of your data exploration work, which is what a lot of data scientists or analysts will do in their role.
Yeah, that's incredible.
So this is one example. Yeah, this is one example of a transform. We have other transforms that allow you to render maps within notebooks. We have transforms that allow you to render VDOM. And transforms are actually pretty flexible as long as you have a function that returns data that is bundled in a certain way and a transform that can consume it. You can create your own custom transform. So some people will create transforms that bundle up with their internal SDKs, export a media bundle in a particular format, and then render a particular UI. For example, if a SQL team might have a particular SDK that they export, and that SDK exports a particular media bundle, and they have a custom transform that is used to render that data in an exploratory tool as well. So this is a way to bridge interactivity and flexibility within a notebook UI by building on standards and specifications around what a media bundle is, and then also React, which is a pretty popular front-end technology and allows people to plug in these components in a really flexible way. So that's a Jupyter notebook with an example of a custom transform rendered using Interact's components and JavaScript packages. And then I want to jump into another example of how you can use Interact by talking about hydrogen. I think it's going to lag. Okay, so this is hydrogen. Atom page, it's got quite a few downloads. I'm actually super proud that it's reached this many because I think it was a pioneer in this space. And you can see hydrogen essentially allows you to, I'm trying to zoom in. This is as far as I'm going. Hydrogen essentially allows you to have a Python document and then execute components within that document the same you would in a notebook. So I can render my Matplotlib visualizations. I can render my data frames. I can do all of these things, but it's a Python file that acts like a notebook. I think my browser is lagging, which is why the Zoom is coming in now. And no, this is, again, the same components that are used within the notebook interface that I showed you and the play interface that I showed you, but it's a completely different form. Because, again, it's about providing these composable front-end components that different organizations and people can use to build their own front ends. So that was really fast-paced tour of the Interact ecosystem. As you can see, there's quite a lot going on. There's a little bit for everyone, from Python to React to JavaScript to all sorts of stuff. So yeah, it's really exhilarating to be part of a project that is leveraging so many different technologies, because I'm always learning something new about something.
Yeah. Oh, I think we may have lagged here, but yeah, the reusability and the composability of all of these components is really, really neat to see.
Yeah, I'm excited about the transforms. I'm going to look into that a little bit more. That seems pretty interesting and related to some things we've been discussing internally for a little bit.
At this point, why don't we go ahead and move over to our roadmap discussion? Mm-hmm. So our roadmap discussion, these are elements of where Interact is going and things in the future of the Interact ecosystem that people can contribute to, or if you're an organization and you have funding and you want to fund different pieces of Interact, these are things and activities that are fundable, and it's where the community is already going. And so, and then your capabilities or your contributions are just help the community get there faster. So, Sophie, if you want to take it away with a couple of roadmap items, that'd be great.
Sure. So I'd say there's a couple of different key priorities that are on the roadmap. The first that people can help out with is the UI redesign. One of the most common pieces of feedback that we get about the UI is that it's not super accessible. There are definitely a lot of accessibility violations, unfortunately. It's not friendly to localization, and there's quite a few improvements that need to be made for it. So we're actually we have hired a designer to produce some design artifacts for the new Interact UI. But we're still looking for individuals who are going to help us with the actual implementation work around that. So if you're passionate about making accessible interactive computing UIs, this is an opportunity for you to help out either with your time or with your money. Other things that we're interested in is efforts around real-time collaboration. One of the features that a lot of people request for in Jupyter notebooks, like I mentioned, they're interactive documents the same way Word and PowerPoint are. People want to collaborate on them the same way they do on a Google Doc. Right. And so we're investing in creating a from the ground up implementation of a Interact front end that is designed for collaborative targets. And we're partnering with the CoCalc project, which already has an implementation of real-time collaboration within notebooks to work on the solution. So that's another one of our efforts. It's an interesting one because it's one of those things that to get there requires a lot of improvements and changes to the way that things are designed and laid out within the Jupyter ecosystem. So if you're interested in that effort and bringing real-time collaboration to notebook documents, there's an opportunity for you to contribute your time and money there. And then finally, it's continuing to improve the Interact SDK. I showed a little bit about how powerful that SDK is, from using it to create things like the Play front end, which is powered by Binder, to having a Jupyter Notebook UI, to having plugins within text editors. All of these things are powered by the Interact SDK. And it needs some maintenance work that's ongoing, but if you have time or money to fund documenting the Interact SDK, providing tutorials and more kind of guides to the SDK, writing more testing, improving the SDK based on customer feedback or user feedback. Those are all opportunities to help make that pretty critical part of the Interact project successful.
Yeah, wow, those are all huge lifts.
I know, we're quite ambitious here.
Yeah, they're great though. I really appreciate the accessibility one, and I know folks have been wanting the collaborative multi-user editing in this ecosystem, in the Jupyter ecosystem for ever.
A long time. It's completely fair because they are documents.
Right,
so.
exactly. Yeah, so just to reiterate your last point there, these are all amazing places to help step in and contribute either code or documentation or funding or any of those things. So if these items scratch your itch, please reach out to the Interact project. So yeah, in the interest of time, we'll move on to our Q&A section. So we actually have a lot of questions here. So thanks, Eric, and thanks, David. So I think, well, I'll just ask one of Eric's first questions, and then we'll get to the other. So the first one is Interact only a desktop app / Atom plugin?
No, it's so many things. It's the desktop app and the Atom plugin, I think, are probably the most popular and well-known Interact tools. But like I mentioned, we've got the SDK, Papermill, Scrapbook, Bookstore, and I consider all of those within the Interact ecosystem because they're designed to plug and play with each other.
Excellent. David, you want to ask David's question?
Sure. What were the pain points that led to the development of Interact?
Oh, that's a good question. I would say it was a need for, initially it was a need for front-end components that leveraged modern technology, had clearer state management, were a lot easier to experiment and play with and build upon than what existed in the Jupyter ecosystem at that point. So it was kind of a developer's pain point. It's like, how do we make it easier to build notebooks and improve that developer experience? And I find that when you improve the developer experience for something, you end up improving the user experience because developers have an easier time working on the actual project. So that was the initial pain point, is let's make it easier for developers so that they can make it easier for their users.
Excellent. Eric's next question is, are there plans to expand Hydrogen to VS Code?
Not at the moment. I would say this is because Microsoft pretty much got their Python VS Code extension pretty well outlined, and they're actively working on developing that. So I would say for anyone who is interested in a Hydrogen-like experience within VS Code to check out the VS Code Python extension. I know there's some gaps in the sense that it doesn't support all language kernels like Hydrogen does, which is something that users come back with often, but that's good feedback to provide for the extension. But so no, there's no plans to do it because VS Code and Microsoft are actively working on it.
David Garrison asks, can we describe the Interact ecosystem as a framework that allows Python developers to create HTML components that enhance data visualization?
Yes, that's one way to describe it. My hesitance in that response is I actually don't think, I strive to make it not be about being a particular type of developer. Like it's not about being a Python developer or web developer, but creating tools that are accessible to everyone, which is why I mentioned earlier our investments in documentation and improving our tutorials in addition to just having API docs. So I think it's the best way to describe it is it's a tool, it's a framework for developers that want to create interactive computing experiences, where interactive computing is just a combination of literate programming and then having some sort of dynamic elements like data visualizations that users are interacting with. So I guess that would be my description of the Interact ecosystem.
Great. So Eric has a few questions that I'll just try to combine and summarize here, but they're mostly, how does Interact interoperate with Jupyter and Jupyter Lab, and Jupyter Hub, and the various Jupyter Lab extensions or Jupyter extensions such as IPy widgets, and what's the compatibility there?
Yeah, that's a great question. So the first was you can run it in a web browser like Notebook or Lab. we do have a nteract Jupyter extension. It's a server extension for the Jupyter server. And that's really cool because it follows up on your second question, which is, can you run nteract as another notebook option in Jupyter Hub, which is the answer is yes. You'll have to configure it as a server extension within your single user servers, and then users will need to be routed to the nteract endpoint on their single user servers within your Jupyter Hub deployment. And then the second two questions are around extensions and IPy widgets, and this is a very interesting space. So nteract does not interop with Jupyter/Jupyter Lab extensions. It doesn't interop with Jupyter Classic extensions because a lot of the way that those are written is dependent on the technology, what the front-end technologies of Jupyter Classic, namely jQuery, and some of the required JS tools for bringing in dependencies into Jupyter Classic. So unfortunately, because it's a completely different front end, the same technologies don't translate. So that's why there's not support for Jupyter extensions generally. I know I get this question a lot from companies who have users who want to install extensions or want to have their own extensions. My general answer tends to be to kind of figure out what functionality you're hoping to deliver as part of those extensions, and then make it a mainline feature within your nteract front end. Because again, with nteract, you build your own Jupyter front end. So the thing that you would have typically done as an extension, you can now do as an actual feature within your product, have it tested, have it go through any security and compliance that your company requires for your product, and just have it be a feature. IPy widgets is not yet supported. There is a design doc for bringing IPy widget support to nteract, and there's some in-progress work, but that hasn't been completed. I guess you could say this is another, it's not on the roadmap because it's not super high priority, but if someone's really passionate about it or interested in it, that's another opportunity for contributions of either time or money, is completing work on porting IPy widgets or bringing IPy widget support to nteract. So yeah, that's the rundown of kind of interop with the rest of the Jupyter ecosystem.
Excellent. Thank you so much. It is now time for our world famous rant section, where we each get 15 seconds to rant about whatever topic we want. Safia, it is your soapbox.
Okay, so I thought of this morning because this always happens to me. I own an iPhone. No one yell and scream at me. There's a maintainer who owns an iPhone. But in the new iPhones, the flashlight icon is in the lock screen. And so what ends up happening is every time I get a notification, if my phone's in my bag, it'll press the flashlight and then it'll turn on and my flashlight's on. And why? Can I disable that? Does anyone know? Maybe I should look into it. I don't always need a flashlight. It doesn't need to be on my lock screen. Maybe I just have to go into my settings and figure it out. But that's what I'm ranting about today.
David?
I've had that. That's a familiar problem to me. My rant is I have too many calendars. I have to collaborate in a bunch of different contexts, which just ends up meaning I have a lot of calendars. And this wouldn't be so bad, except some of those calendars are like behind firewalls, which means that I can't actually reconcile the calendars completely. So I have to consult multiple calendars just to determine what my schedule is for the day. And it's just, yeah. The worst is when you actually can collaborate on the calendars, but you put the entry on the wrong calendar. It's just getting to be a little bit too much.
I feel your pain there, David. For my rant this year, at SciPy this year, they introduced an amazing Ethiopian blend iced coffee. Please keep doing that forever.
Oh man, I'm jealous.
I know, it's really good.
Jealous.
It's really good. That's all the time that we have for today. Thanks for watching. Thanks for listening. You can find us on Twitter at Quansight AI. If you're interested in funding open source projects, including nteract, you can find all of the project roadmaps at quansight.com/projects. Safia, where can people find you and nteract?
You can find me on Twitter. I'm Captain Safia there. Nteract on Twitter is nteract, NTERACTIO, and also nteract.io on the web. And you can also reach out to me via email, safia@safia.rocks, if you would like to get in touch about contributing or donating to the nteract project.
Great. And be sure that your calendar is all tied up for our next episode on Binder. Thanks, everybody.